Hello everyone. This video is a recorded presentation of our project proposal. Our project is titled as Robotic Twine, an Intelligent Companion for Rehabilitation. The team members are myself Mandira Roy and Professor Nabendu Chaki from University of Calcutta, India. Let's begin. Caregiving is one of the most demanding jobs in healthcare. It is found that the caregiving process is often more resource intensive and critical than the actual treatment phase. It involves a diverse set of patients, like someone who is recovering from a major accident or someone suffering from chronic illness. It might also involve patients whose illness may not be that life-threatening like Alzheimer's, but still requires a constant care and support from a caregiver. Human attention span has its limitations due to very natural causes such as fatigue. Also, in the existing healthcare scenario, the patient-caregiver ratio is a highly imbalanced and requires proper addressal. In this project, we want to explore the precision, accuracy, and dependency of robotic systems in order to integrate it within the rehabilitation process. This project proposes the design of a robotic twine that will assist the patients in rehabilitation. The idea is not to replace the human caregiver from the process, but to empower it with a digital twine version of himself or herself. Now, in order to do so, it is very important that the human cognitive abilities need to be integrated within the robot. The robot will learn from the caregiver and adapt accordingly. It will also assess the physical and emotional states of the patient in need and tailor its support accordingly. This is the operation architecture of our proposed robot twine system. There are several components that are there in this proposed architecture. The first one is the robot twine itself, then the patient or the rehabilitant, someone who needs the care. We have the caregiver, then there will be external sensors also, like for measuring temperature, humidity. Then there will be sensors that measures the patient vitals like the heart rate, blood pressure monitor, and so on. There will be also a microcontroller such as Raspberry Pi, which will be used for processing the data received from these external sensors. Uh, a dedicated network infrastructure that will help the communication between this heterogeneous set of devices. And another key component is the robotic twine application. It is a mobile software application that will act as a gateway of communication between the caregiver and the robotic twine. Now, this application will help the caregiver to send prompts or instruction to the robot as well as to receive patient-related data such as status of the patient from the robot. Now, when the robotic twine is actually deployed for operation, it will be responsible for continuously monitoring the patient without causing any hindrance. Now, the idea is to foster independence among the patient so that it does not feel constantly monitored by someone or something. Next, when the robot twine will observe some kind of discomfort or distress within the patient, it will try to process the vitals data of the patient and also data from external sensors such as temperature, humidity measurement of the current environment. If it can infer the cause of the distress, it will try to take some course of actions on its own. If it cannot infer the cause, it will be responsible for sending an alert to the caregiver. In this case, the caregiver will be expected to attend the patient as soon as possible, whereas the robot twine will learn from the actions of the caregiver such that in future when similar situation occurs, the robot twine can handle the situation in a more better way. Okay, now let us consider these two figures. So we can see that these two images are basically of the same human person. Now on the left hand side, we assume it is the image of an actual human caregiver, whereas on the right hand side, it is the robotic twine version of the human caregiver. Now we will learn how the robotic twine will be learning from the human caregiver, and also how it will be built, that is the robotic twine software, so that it can handle or assist the patient in their rehabilitation. So the robotic twine software or its decision making engine will use machine learning models. The machine learning model will be a combination of two hybrid approaches. One is the neural network, which is an excellent supervised technique for handling known data sets, and the other one is the reinforcement learning, which will be used such that the robot will be able to make decisions in unknown environments or unknown situations. Several data sets will be needed in order to train the neural network. Some of them are the healthcare data set that will comprise of the symptoms, diagnosis, and the medical conditions that the patients may have. Next is the behavioral data set that will be responsible for uh, uh, containing the actions and the speech or the emotional states of the humans. Now, this dataset is very important as it will help the robot to infer the different emotional states or emotional signs of the human patient. Apart from this, when the robot is deployed, it will also contain some specific data set such as treatment administered, treatment outcomes, and so on. The neural network will be trained on this diverse set of dataset, and as a outcome it is expected to produce thresholds, actions, and alerts. Once the initial software will be built, it will be tested in a simulated environment, and it will be expected to go several phases of retraining in order to make it more robust to work in unknown situations. Now, when the robot will be deployed in an actual environment and its sensors identify some distress in the human patient, the neural network model will be responsible for generating the course of actions or the thresholds and the alerts that the robot may give. Now, this set of knowledge will be fed to the RL agent, that is the reinforcement learning agent, and the agent will be responsible finally for taking the actual set of actions by the robot. This set of actions by the robot will be continuously monitored by the caregiver, who will be responsible for providing feedbacks. This feedbacks will be further used for penalizing and rewarding the RL agent. This process will continue, that is, the several phases of learning or training of the robot will continue, and finally, it will reach a state where its abilities are much closer to a human like decision making. So now let us see some use case scenarios where we will show how the robot twine will help patients in their distress. Video shows the scene of an elderly woman suffering from anxiety and speech disability, taken care by rehab robot. The actors in the scene are Mary, an elderly woman, Terry, the caregiver or a family member, and rehab robot, the robotic twin. Scene will depict how rehab robot will assist the woman at night when the caregiver might be resting and the woman shows signs of distress.
Help, help. I am here, Mary. Water, water. Water is here, Mary. Drink, Mary. I am here. Relax.
So, in this scene, we can see that the robot was very prompt in reaching a decision when it observed that the woman was in distress. This happens through several phases of training and repeated learning from human caregiver of similar patients. But this might create a bias within the decision-making process of the robot when it keeps on learning from same type of caregiver handling same type of patients. But this can be managed or encountered through our robotic twine application. The robotic twine application gives the caregiver the freedom or the ability to instruct the robot in a particular manner or specify the course of action the robot should take in certain scenarios. This video shows scene of a young athlete woman recovering from sports injury supported by rehab robot. The scene consists of Nancy, a young athlete woman, and rehab robot, the robotic twin. The rehab robot will provide professional support to the woman.
I don't feel good.
How can I help you, dear?
I feel I may not get better.
Here, let's try to exercise a bit. You can do it, Nancy.
The robot will provide daily reminders to Nancy.
Time for exercising, Nancy.
The robot twin will help Nancy through all stages of her recovery. It will be acting as a dear friend to her. So the scenario 2 shows how the robot was a great friend in the recovery of a young athlete who was going through several emotional changes along with her physical recovery. Uh, Now, building such a robot twine system is challenging with respect to training the neural network with the right set of data sets. However, apart from this, there are other key considerations like the security and privacy of the data, as the robot will be responsible for handling very sensitive data with respect to human patient. Another thing is the social acceptance of such a system in the healthcare system. This can be managed or encountered by working in close collaboration with the healthcare professionals and making them understand that how such a robot twine system or a humanoid in the form of a caregiver can empower the healthcare system and make it accessible to a wide population. So that was our presentation. Uh, Thank you for your kind attention.